Good afternoon, folks. Thanks for joining us today, and I'll talk around AWS landing zones. My name is Jamie Walker. I'm a Senior Solutions Architect at Steamhouse. I've been with Steamhouse for around 5 years now, and predominantly over the last couple of years, we're focusing on serverless and containerless workloads. I'm also an AWS Community Builder on the serverless track.
Hi everyone, so my name is Paul Flowers and I'm a Solutions Architect at Steamhouse as well. I've been designing and building platforms on AWS for about 6 years or so now, and I'm also a Community Builder on the containerization platform. So today we're going to be talking about AWS landing zones and basically discussing some of the core components that you might consider when building your own landing zone, as well as some of the key considerations you might need to take along the way. So to start off with, what is a landing zone? So a landing zone is a well-architected, multi-account AWS environment which serves as a starting point upon which you can build any kind of AWS platform or AWS environment. So whether you're using a containerization system like EKS or ECS, it's completely serverless, or you are using classic EC2 and virtual appliances, there are common foundations or building blocks that all of these will share and have in common. So some of those considerations and the commonalities that you might look at are things such as backups. So you should always have backups before you've even designed a workload or built an application. You know you're going to need some form of backup mechanism and somewhere to centrally control and manage and store that. So whether that is just using snapshots or data lifecycle manager, or if it's using the full AWS backup suite. Alongside that, you know you're also going to need logging. So again, before you've even designed your application, you know that you're going to be outputting a lot of different logs at various different levels, and you're going to need a central place to actually ingest these and collate them. It's not only application logs, but also VPC flow logs and API logs through CloudTrail and things like that. Having a standardized, centralized place where you can sift through those and pull out findings is always useful. In a similar vein, there's observability and monitoring is also another centralized aspect that you want to try and bring that into a specific role and specific account. So whether you are using CloudWatch, whether you are using sort of Datadog or Swank or another service like that, it's setting the guardrails and the centralization for that. Another main or key aspect of the landing zone is also your network design, your network topology. So regardless of what actual platform you end up building, you know you're going to require some VPCs at some level for ingress and egress or for talking between services as well. And the next consideration is also around security. So having guardrails in place, defining human access, encryption standards, as well as compliances, and having a centralized place to track that and monitor for conformancy. So as I said right up at the start, that a multiple account strategy is a really core aspect of that landing zone development. So when I first started building on AWS, the common pattern was to create a single AWS account, and in that you would kind of shoehorn all of those components that I just talked about, and there would be no real hierarchy or separation of roles. Now, due to the way that AWS has matured or cloud operations have matured and some of the service offerings that provides us, we start to actually silo those and build them out into individual accounts so we can actually create logical boundaries around those. And so we tend to do that by, we group things together. So if you have a particular set of workloads, you can group them into a workload-specific account, and we can apply distinct controls around them and limit the blast radius of any adverse events as well. So with that, I'll pass it over to Jamie, who's going to talk about AWS organizations.
Cheers. Okay, so yeah, we talked about that multi-account structure is the best practice recommended by Amazon. And how can we go about achieving that? So AWS offers a service called Organizations that allows us to centrally manage and govern your multi-account structure environment. And there are some key features of organizations that we're going to go through today, and the first of which is central account creation. So this allows us to kind of self-explanatory, but organizations allows us to create and manage our accounts with a couple of clicks in the console or via the organization's APIs. Once we've created these accounts, it'd be nice if we could manage a hierarchy of them that kind of conforms with our business structure. So we're able to do that via organizational units, or what are commonly known as OUs. So OUs are, as I say, logical groupings of AWS accounts, allowing you to create that hierarchical structure within your environment. And then you can apply management controls to these OUs. And as a best practice, it's best to kind of design your OUs based on function. And we've got a sample OU structure here. which contains, it's kind of quite basic, but this would be a good starting point. So we have the top a security OU, which might contain our security account, logging, etc. Then we're going to have a shared infrastructure account, which might contain our networking account and backups. We then have, we can also nest OUs as well. So we could create a workloads OU and then nest one or many workload OUs within that if you want to separate them out by team, for example. And then finally, we may have a deployments OU where we can centrally kind of manage the deployments via different workload accounts. The next feature of organizations is service control policies. So service control, or SCPs. So SCPs provide centralized governance around the permissions within our organization. So SCPs define preventative guardrails and set limits. So unlike IAM roles, they don't provide access to resources. They are designed to kind of prevent access and limit what we do in our accounts. So for example, you could have an SCP which might limit the regions that we're able to operate in, or you might have an SCP which limits IAM roles from creating resources without specific tags. That kind of segues me on nicely to the next benefit of organizations, which is tagging policies. So tagging policies allow us to enforce certain tags against resources. You might apply an environment tag, an owner or project tag. This is incredibly useful for like billing purposes. If you operate different, if you're a large business and you operate different cost centers, for example, this can be really useful and helpful for your finance team to differentiate where that cost is originating from. And it's also useful for backup. So that leads me on to another feature of organizations, which is backup policies. So backup policies allow us to define rules around how and when our resources are backed up. It's kind of tightly coupled with the AWS backup plans service and can be applied to the root of our organization, the OUs themselves or individual accounts. So for example, you might create a default backup policy at the root of your organization, which backs up all the DynamoDB tables across your organization. And what we're then able to do is define more granular backup policies at an OU or account level, which might override the frequency that we're backing those resources up, depending on your business requirements. And as Paul alluded to earlier, it's kind of best practice these days to be managing these backups in a centralized location, so in a central account. And what we've generally done with customers is we create that backup account, and then we'll have backups carried out in the workload accounts themselves, and then we'll perform a cross-account backup to this central backup account for archival purposes. And it just means if there are any adverse changes to that workload account, the source account, we're able to actually copy those backups back and restore them where needed. So finally, I think this is probably one of the most key benefits of organizations is that it allows us to use centralized billing. So all the bills for our accounts are consolidated into a single bill, which is extremely useful. But as we've kind of mentioned a few times up to now, tagging is extremely important if you're going to follow this approach because you're able to then differentiate the spend and where, which teams are kind of and resources consuming that spend. So I'm going to hand over to Paul now to kind of discuss other considerations that you might need to think about when designing your landing zones.
Cheers, thanks, Jamie. So Jamie and I are in a very kind of fortunate position with the roles that we are in, where we get to work with a large range of different clients that are all at different stages of their cloud journey, if you like. And because of that, that means we're able to identify a lot of areas where there is commonality between different use cases, depending on sectors and things like that. But one of the other key things is where they actually do start to differentiate because of organizational needs. So the main area where we see that kind of differentiation is within network considerations and how you actually design your topology. So typically there are three primary designs that you might pick up. So the first one being a mesh network or VPC peering. The next one might be a hub and spoke or transit gateway based topology. So these are all based around the idea of having a VPC per account, so a VPC per workload, which can sort of span into multiple different accounts as well. And the third option, and a more sort of modern approach, is to utilize VPC sharing. So I'll kind of run you through the three different sort of technologies or layouts. So in a VPC peering configuration, you can see here, that's your mesh-based topology. So each VPC is allocated to a specific account. So if you're fully following that multi-account structure, you will have a production workload account with a VPC in it. You might then have another account for your finance infrastructure and another account for fulfillment or warehouse services and things like that, and it'll all diversify and break down. So you end up with this big web of different VPCs that then need to be interconnected. And here we're using VPC peering to facilitate that for us. So some of the things around VPC peering is that it works really well when you have a small number of VPCs. So I think Amazon sort of recommend less than 10 is the kind of the sweet spot. In my personal experience, once you start to get over maybe 6 diverse VPCs, because it's bi-directional, you need to configure it in 2 places at once. You're basically talking about 12 different places you need to configure that peering connections to create your mesh network. So it can get quite complicated quite quickly. It is, however, one of the most basic methods for interconnecting a VPC without the use of an appliance. So it is literally built straight into the VPC console. If you have created a VPC in any workload account, then you are fully aware of all the terminology and what is required to be able to actually facilitate those VPC peering connections. Another great advantage of VPC peering is that it is really low latency. So if all of your workloads are actually defined in the same region and across the same availability zones, the chances are all of your VPCs are actually using the same switching gear behind the scenes. So it's a hop at most to kind of get between those, and it's just straight down the cable. So really low latency. However, as I was saying, as your organization starts to grow, so you start to then work on an additional project, say you're selling bicycles 1 minute and then the next you're selling pushchairs or something else, you're then starting to create even more AWS accounts to facilitate all of these projects and all of these workloads. So once you kind of start growing and you've got 20 or so different accounts, it becomes a real mesh and quite difficult for a network operator to keep on top of the different CIDRs and the route tables and things like that. So the alternative approach is utilizing AWS Transit Gateway to provide this hub and spoke style system. So you still have those independent VPCs for every single workload, but you have this central transit gateway, which they are all hooked into to provide interconnectivity between them. So some of the advantage on that is, as I say, it provides that hub and spoke design to interconnect VPCs. It also allows you to control an entire organization's routing configuration in one place with lower complexity. So if you have, as part of your landing zone architecture, you define that all VPCs, they either route to the public internet, they route locally, or they are sending any sort of private CIDR straight back down to that transit gateway, you've already taken care of one side of this arrangement, and you only ever need to access that networking account where you have your transit gateway, and you modify all of your connections in there, and you define all of your routes in that one centralized place. This is the default or the most common network architecture. So if you ever start with a new company or you start working with a new organization, more often than not, this is the kind of setup or arrangement that you're going to see. Another advantage of that is that it's well documented by AWS, and there's a lot of community support around it as well. Some of the things to also consider, though, is that it is higher latency because you're not just running straight through switching gear. You are going off to a managed virtual appliance. It's doing some computation there and then firing it back into that AWS backbone. So there are additional hops and there is more latency. So if your workload is sensitive to sort of latency and things like that, it might not be the best fit for you. And the other thing to consider is that it does incur some costs. So it's about 6 cents per hour per VPC attachment or per subnet attachment, and about 2 cents per gigabyte of data that transfers that transit gateway as well. So the other approach, and a more modern kind of solution, is the use of VPC sharing. And this is one I think it's safe to say we kind of champion in Steamhouse for different customers if they haven't got any particular requirements around the network isolation. And this is essentially a system where you create your VPCs just in a networking account. You create them centrally, only in that one place, and then by utilizing Resource Access Manager, you actually share those VPCs into your particular workloads. So in a situation where you have those 20 accounts, instead of having 20 distinct VPCs, you now just have a production or a non-production one in one account, and Resource Access Manager is providing those to the workloads that sit underneath it. So some of the things about VPC sharing. As I say, it creates a full separation of duties. So you have centrally controlled VPC structure with your routing, IP address, and IP address allocation. So your infrastructure engineer or your network engineer, whoever, just works within that one networking account, and they can handle and manage everything within there. The other main advantage of this is that application owners continue to own their resources, accounts, and security groups. So from an application owner perspective, this is a completely transparent sort of change to your topology. They can still create load balancers in the public subnet, still create your compute workloads in those private subnets, and they can still attach security groups directly to those services. So you don't need to go into that network account to handle firewalls and security ruling. You can actually do that all local to your applications like you would in a traditional environment. Along with that is that VPC sharing participants, so each account that's sat on that shared network, can actually share security group IDs between them. So if you have a data analytics account, so that's a separate account, and that is sharing a production workload with your bicycle and push share sales, for example, if you need to then gain access into them, you create a security group on the ingress of whatever your data analytics software is, say it's security group 1, 2, 3, you pass that over to your database administrators in those workloads, and they can just whitelist it there. So it's not based on CIDRs. It's almost as if they are living in the same account. The accounts are just creating logical boundaries. Another aspect is that it creates higher efficiency, so you get a higher density of subnets. Generally, when you create a subnet, you're going to do like a /16, and it's like 60,000 IP addresses or something like that, which you're rarely using. So it enables you to, like I say, create a higher density, higher usage of those subnets. It also allows you to make efficient use of VPNs as well. So where you have multiple different VPCs, you might have a VPN to access each individual one. In this shared network setup, you only need a production and a non-production VPN that's actually configured in those networking account directly. And again, using those shared security groups, that's how you can control access to the resources underneath. So again, it's consolidating a lot of the networking overheads. And the final point on that is that it also allows you to optimize costs through the reuse of NAT gateways and VPC interface endpoints. So, like I say, if you've got those 20 different accounts that are underpinning your workloads, you're looking at 60 sort of NAT gateways, and as your organization grows and you take on new projects, you're adding more and more NAT gateways into that. In this arrangement, you're only ever going to have six NAT gateways that you need to pay for, and that becomes a static cost, so you don't need to sort of worry or consider that. Another key aspect is around these kind of considerations is also related to security hubs. I'll pass over to Jamie, who's going to take you through that as well now.
Cheers. Okay, so one of the next considerations, potentially one of the most important ones to think about, is security. So security should be at the forefront of our plans when designing our landing zones. And defining a well-architected security posture will stand you in good stead throughout your journey on AWS. And as I'm sure you're fully aware, AWS offers a range of security services that allow us to harden our environments. However, today we're going to focus on Security Hub in particular. So Security Hub aggregates and normalizes findings across our security services and provides us with a single pane of glass view of our security posture within our AWS environment. So some of the key features of Security Hub are first and foremost security checks. So Security Hub will continuously run automated checks across our AWS services and in resources to ensure that they align with best practices and also some regulatory frameworks. And these checks are applied via one of many predefined security standards that we're able to leverage in our organization through Security Hub. These standards are CIS, PCI, DSS, and AWS Foundational Best Practices. So an example of that would be that, for the PCI DSS standard, it consists of a set of controls that are applied at an account level. So, for example, one of these controls might be that ALB should be configured to redirect HTTP traffic to HTTPS. And that directly links with one of the PCI DSS requirements for safeguarding customer cardholder data. So it doesn't make you compliant, but it kind of sets up the framework to kind of for that compliance. One of the next benefits of Security Hub is automated remediation. So you're able to take action on any misconfigured resources or services via remediation workflows. And you're able to leverage services such as Lambda or Systems Manager automation to apply that remediation. And the way that Security Hub achieves this is by continuously streaming these security events to EventBridge, where you can then configure custom rules to respond to each type of event. So an example of that might be a custom action in Security Hub that detects unencrypted cloud trails, and then you might invoke a Lambda automatically to go ahead and remediate that and encrypt those trails with KMS. AWS actually offer some useful off-the-shelf solutions for cross-account automated response to remediation, so I would definitely recommend reading the documentation around Security Hub because they may offer plenty of what you need out the box without too much effort. So the next benefit I want to talk about is delegated administration. So what we would recommend, and we kind of discussed this earlier, is creating a security OU and a security account within that OU in your organization. And the idea is that you would make that account the delegated administrator of the Security Hub service. What that does is provide that clear separation of responsibility that we've kind of discussed numerous times now. You don't want to be managing that in your organization. You want to kind of keep that separation and boundaries. And what that allows you to do is then enable Security Hub across all of your accounts in your organization, as well as any new accounts that get added via your organization as well in the future. Next, Security Hub also offers a number of service integrations, both with AWS and third parties. So some examples of those are AWS Config, Guard Duty, IAM Access Analyzer. In terms of third-party integrations, we can integrate with Jira, so we're able to automatically create incidents in our Jira organization based on these security findings. And then similarly, we're able to use OpsGenie to route these findings to the appropriate teams so they can take the relevant action that they need to do. So in summary, Security Hub provides us with a simple way to continuously monitor our services and resources in this multi-account environment via AWS organizations. I'm going to hand over to Paul now to talk about SSO and identity management.
Cheers, Jamie. So further to that, not just the actual security of your accounts and your infrastructure, actual human access and personnel security is another key factor. And again, it all comes down to that centralization of controls. So what was formerly known as AWS SSO is now the IAM Identity Center. And what IAM Identity Center provides to you is a single sign-on service to AWS, so into all of your AWS accounts and into third-party applications that are SAML2 compatible. A great feature of this is that it allows you to centralize management and access controls into one account. So previously, SSO had to be enabled in your organization account and managed there. In the last few months, they've enabled the ability to actually delegate that out. So again, you can put that into a security account and manage it under a security OU, rather than having to give people access to your organization to actually manage users and things like that. Another really good feature is the use of permission sets, so it allows you to be really granular and apply fine-grained access controls to your users. So if you have someone who works in finance, for example, who just handles the billing of those AWS accounts, they can be assigned a finance role or finance permission set, and they will only be able to access the billing tools in those AWS accounts in that AWS console. Further to that, you can customize and extend on these. So there's a lot that are provided by Amazon out of the box, but by using the kind of familiar IAM syntax, you can actually extend on those and start to be really granular. So providing developers with only access to one particular cluster within a workload or something like that. Another really cool feature about using SSO and centralizing that access control is the ease of revocation. So if you have a third-party security analyst, for example, who comes in, they just spend 3 weeks, say, analyzing some of your workloads. Instead of having to jump into every individual account, grant them their access, and then revoke it at the end, it is all managed in that one place. So it's really easy to manage individual user access. And as I said at the start, it has a full SAML2 based integration, and that integrates with a lot of AWS services as well. So you can use the SSO portal to authenticate with the AWS client VPN, and you can also use it to authenticate with OpenSearch Kibana dashboards and things like that. Another great part of the IAM Identity Center is that it will integrate with third-party providers. So if you already have an SSO solution at the moment, you can actually utilize those as your identity pools and still take advantage of what IAM Identity Center offers to you. So things like Jump Cloud, Okta, OneLogin, I think you can even integrate with Azure AD if you wanted to. So yeah, loads of great features built into that SSO console that you can work with and allows you to centralize that human access as well as focusing on individual service level of security. I'll pass over to Jamie, who's going to sort of take you through some infrastructure as code management.
Cheers. Okay, so we've talked about general design best practices for our landing zones, but we still need to consider how we're actually going to configure these landing zones. So they've got many options available to us, but what we're going to talk about for the next couple of minutes is infrastructure as code management. So first and foremost, and we're kind of heavy advocates of this approach, is we should be designing our landing zones with repeatable infrastructure as code and automation in mind. And there are a number of tools and services that we can use to achieve this. But before we go into those, I'd like to see a show of hands for anyone that's managing their infrastructure via the console at the moment. Don't be ashamed. We're not judging here.
Correct answer.
That's good. That's positive. Okay, so let's dive into these tools. So the first of which is AWS CloudFormation. We then have HashiCorp TerraForm, the AWS Cloud Development Kit, and Pulumi. I'm just going to talk about a couple of those in a little bit more detail now. So the first of which is CloudFormation. So CloudFormation is a native service which allows you to define, provision, and manage your AWS infrastructure by treating it as code. And some kind of key features of CloudFormation are first so that we define our infrastructure in templates. So templates are just simple text files that you can author in either JSON or YAML. If you're crazy. Stacks. So the next benefit of CloudFormation allows us to group our resources into stacks. So stacks are a collection of resources that allow you to manage those as a single unit. And for example, we might have a stack that represents a web application that might include an application load balancer, an ECS service, and a database. But you could then drill down even further if you like and separate those into separate stacks. For example, if you've got a team that manages the database administration side of things. And what that does is it helps to then reduce the blast radius between those resources. So, any adverse changes to one won't affect the other. The next benefit of CloudFormation is it provides a bunch of built-in functions that we can leverage to do things like retrieve data from our accounts or between different stacks, which is extremely useful when we're kind of like building out these landing zones. The next benefit is it offers a lot of service integrations. Naturally, being a native service, it ties in directly with many AWS services. However, what I would say is that when a new service or feature is released, it doesn't always get supported immediately. It can take time because it is a closed source solution. Next, the next feature I want to discuss is change sets. So change sets allow us to kind of get a glimpse of into the proposed changes that our code is going to make or introduce into our environment that could potentially affect running resources of service. Now, this is extremely useful just to kind of ensure that we're not going to apply any breaking changes, etc. Okay, so the next tool I want to discuss is the AWS Cloud Development Kit, or what's more commonly known as the CDK. So the CDK is an open source development framework that allows you to model your AWS resources using familiar programming languages such as Python, TypeScript, Java, and more recently Golang. The interesting thing about the CDK is essentially a wrapper for CloudFormation. So the AWS toolkit at CLI essentially synthesizes our CDK applications into CloudFormation templates. And then it can manage the deployment of those templates into our stacks in our accounts. However, you could just as easily kind of take those templates away and wrap them into your existing CI/CD tooling if that is more preferred approach. One of the core features of the CDK are constructs. So constructs are the building blocks of the CDK, and they represent a component in your environment which can comprise of one or many resources. So AWS provides us with a construct library that provides a large number of these constructs. And the constructs are categorized into three levels, which range from being able to create individual resources that are available via CloudFormation through to what are known as patterns. So, for example, there's an ECS pattern that allows us to deploy a load-balanced ECS Fargate service with just a few lines of code. So it abstracts a lot of that configuration away from us and make things a little bit simpler. Another benefit of the CDK is it allows us to use common programming idioms such as loops and inheritance. And further to that, we're also able to treat our CDK application code in the same way that we do our normal application code, so it can live alongside it in your repositories. And that means we're able to then follow the same branching and development workflows that you're kind of familiar with. So that's really useful as well. I'm going to hand over to Paul now to discuss some additional tools that you can use.
Awesome, thanks, Jamie. So another really popular infrastructure as code management tool, as we pointed out earlier, was TERRAFORM. So some of the advantages of TERRAFORM is that it is an agnostic tool set which has multiple provider support. So you can use it across various different cloud providers. You can integrate it with Kubernetes or with Helm, and you can even orchestrate things like Datadog and Splunk with it. So you can incorporate monitoring as code as part of that landing zone as well, which means you're able to completely standardize your entire stack in one configuration language. Another nice feature, or I personally think, is that you write it in HCL, HashiCorp configuration language, and this is a really easy to read high-level language. So I know I've spent loads of time trying to trace YAML with my finger to figure out how nested a value is, but HCL makes it really easy to define that and see that. Another great advantage is that it provides a number of third-party modules, so for handling things like VPCs, transit gateways, EKS clusters, and IAM roles. So with just a few lines of code, and just by passing in some configuration variables, you're able to set up a best practice VPC. You're able to set up those transit gateways we were talking about. And like the EKS one is incredibly powerful. Not only can you manage your control plane with it, but you can do managed node groups, security groups, EKS add-ons, and everything just within one module with a few bits of configuration. So it really wraps the resources up nicely for you. And another advantage is that it is often ahead of CloudFormation as well. So when a new service hits general availability in AWS, more often than not, from day one, it will be available to use in Terraform as well. Whereas Jamie says, you might be waiting a week or so before CloudFormation actually catches up and releases that. So another tool to kind of encompass and wrap Terraform up is the use of Terraform Cloud. So Terraform Cloud essentially provides centralized runners for Terraform. So it allows you to create almost like a pipeline for your infrastructure code and infrastructure management. And having these centralized or remote runners means that you're not having to set up Terraform on your local machine and make sure that all of your operators are running the same versions and things like that. It's all offloaded for you over in the cloud. Another nice feature of Terraform Cloud is that it provides a GitOps workflow, or it ties really nicely into a GitOps workflow in the sense that when you create a pull request in your infrastructure repository, it will automatically run a speculative plan, and it will show you what changes are about to be made before you merge that into your main branches. Hang on. Another really cool feature is that it supports remote state management. So rather than having to find a way to share that state if you're running it locally, or traditionally I think we used to use S3 buckets, which also meant that you were storing your state alongside your application workload, which isn't necessarily a great thing to be doing. It will actually offload that state management for you and version controlling and things like that as well. So if you're already working with Terraform and you are using S3 for remote states, you can actually migrate into Terraform Cloud, make use of that remote state management, and you don't need to change your workflow, so you don't need to use the centralized runners. You can continue to just implement it the way that you do. One of the sort of things to be aware of, though, with Terraform Cloud is that it does rely on the use of IAM keys. So you do have to make an IAM user with programmatic access keys and provide full access into those AWS accounts. So depending on certain compliances that you might need to meet or security practices, it might not tick those boxes for you. And another really cool feature about it, though, is that it does support drift management. So if some scallywag's been in your account making manual changes, it will automatically detect that for you, and it will tell you that there's been a change against the state that it recognizes. And it will also provide cost estimation, so you can see what the damage will be before you actually merge anything into your main branch. So that kind of covers the infrastructure as code side of things and what you'd do if you wanted to self-build your own landing zone. But there is a more kind of off-the-shelf solution, I think would be fair to say. And I'll let Jamie talk you through that as well.
Cheers. So yeah, as Paul said, I think we can all agree that infrastructure as code does save us the headache of having to manage our infrastructure by hand, and it provides us with many benefits. However, AWS do offer an alternative solution which will suit like a large number of customers, and that's the Control Tower service. So Control Tower provides us with a simple way to set up and provision a best practices multi-account AWS environment directly via the AWS console. Control Tower integrates with other AWS services to provision, firstly, a multi-account structure via the AWS Account Factory, which is essentially just an easy way to create and manage your accounts and OUs within the Control Tower console. It also integrates nicely with IAM Identity Center to kind of manage the secure access to your AWS environments and applications within your environment. Control Tower also applies a set of guardrails for us, and we can enable and disable some of them. Some of them are required, but essentially these guardrails are high-level rules which provide ongoing governance for our overall AWS environment. And Control Tower implements these preventative or detective controls that help you monitor the compliance across your accounts. So you can apply these guardrails to each OU or account in the OU. And it also provides this single pane of glass view of like your compliance across your environment, which is extremely useful. Another benefit of Control Tower is that it is extensible via what's known as the customizations for Control Tower solution. I haven't used it, but I'm aware that it's a stack that you deploy into your accounts, and essentially what it provides us with is a mechanism to customize above and beyond what the Control Tower service provides us out of the box. And it does this using the Control Tower lifecycle events to ensure that your accounts stay in sync with any of these customizations that you've applied, and you apply these via CloudFormation templates. Something else to bear in mind about Control Tower is that it has been designed with best practices in mind. So it's been taken into consideration many of the customer engagements that Amazon have undertaken over the years, plus recommendations from white papers, documentation, and the well-architected framework. It is an opinionated and prescripted service, so it might not suit everybody. So the best thing to do is to read the documentation to ensure that it meets your requirements, make sure that you're aware of any limitations before going ahead and deploying your landing zone with Control Tower. But with that being said, its main benefit is that it accelerates your journey on AWS. So if you're looking to start building rapidly and you want to you don't have the familiarization with IAC, you want to kind of ensure that you're building on a best practices foundation, then Control Tower could be the service to provide you with that. So there is an alternative solution. I kind of briefly touched on it there, but you're obviously able to then combine the approaches. So you could use Control Tower to kind of rapidly build that landing zone and then apply all the other kind of bells and whistles around it, whether that be networking, etc., with an IEC tool of your choice. Now, there is actually another ready solution on the AWS Samples GitHub project, which is called the AWS Secure Environment Accelerator. Something I've reviewed recently for one of our customers, and what it provides is a fully fledged, highly customizable landing zone, including all the things that we've discussed today, such as networking, and it can actually be deployed on top of Control Tower as well. What it does is it provides you with some really good documentation and some various configuration options, so you can start with a simple landing zone, or you can kind of go with a fully fledged, highly complex landing zone to meet your business requirements. Okay, so that covers everything from us today. So thanks very much for your time. I appreciate it. I'm going to open up some questions, I think.
Okay, first question. Aled.
So when to choose Control Tower? Like, completely take your point and read the documentation, but customers don't want that answer. They want guidance as to when it's going to be the right solution. So what kind of teasing questions would you ask? What guidance would you give for whether to choose it or not?
I think I briefly touched on it. So I think you need to evaluate the skill sets around your teams. So and the knowledge around your teams, right? So if you've got knowledge of the best practices and you're able to then leverage something like Terraform or CloudFormation to build this out from scratch, that would be our preferred approach. But not everybody has that fundamental knowledge. So Control Tower does, like I say, allows you to rapidly get started with building Amazon with the best practices landing zone. That's my kind of use case at the moment. I've only used it a couple of times with some customers. So as I say, our preferred approach is to customize the whole thing from scratch. But yeah, that generally it's kind of evaluating your skill sets internally and just identifying if it does suit your requirements. But reading the documentation is something I would advise.
Okay. Erin.
I was just wondering, so I used to look after the UK Home Office's environment in terms of we had 150 different accounts. We'd been doing cloud for several years. And when we came to assess, okay, we want to do landing zones, it was difficult to make that decision from what's best to implement when you've already gone down the bad path of, I've never done this before. So if you were to look at all the options you've presented and for enterprise customers or people who've already got loads of workloads and have never done this, which would be the first one to look at? I mean, you've already said Terraform, because I think, like, my issue, for example, with, like, AWS Control Tower, it can be quite restrictive. It kind of limits you in a set path of set configurations, and it's hard to make your own governance decisions sometimes, but yeah.
Yeah, it's difficult. I don't know if you want to answer this. I'm happy to.
I think it's more Control Tower based.
So it's a difficult one. It's just, again, it's a case of like your knowledge internally within your teams. But from in terms of choosing the correct tooling and stuff, again, it depends on the skill sets. We at Steamhouse have built our own landing zone with Terraform and Terraform Cloud. That is our preferred approach. And to be honest, we believe it's best practices. And what we did is we just reviewed the various white papers around security and networking and just took guidance from Amazon ourselves to kind of establish what we believe to be the kind of common set of building blocks that customers are going to need. But I mean, I'm happy to have a chat with you afterwards to discuss that in a bit more detail if you want some more information.
Okay. Anyone from this? That's nice and close. Nice and close. Perfect.
Is there any time where you'd recommend sort of native cloud formation over, say, CDK or Terraform?
Personally, no.
I thought that'd be the answer.
Yeah, so I would avoid it. I wouldn't touch it with a barge pole. But to be fair, we know a lot of customers that use it very successfully. So yeah, I wouldn't be so harsh on it. CDK, I've been using it recently, and I'm actually quite surprised that, well, it's been a love-hate relationship. I've enjoyed using it. It kind of simplifies a lot of things. But yeah, in terms of, Paul discussed earlier, in terms of Terraform, HCL is just much more readable and easier to use, and also it's easy to read if you're unfamiliar with like the language itself. Anyway, it's kind of fairly self-explanatory, isn't it? What about you? Have you got any input on CloudFormation?
Yeah, again, I think it kind of depends on the knowledge and the skill set of your internal teams as well, and what level of abstraction you want to kind of provide to them. So how far you want them to be able to manage themselves versus how much you want to actually sort of navigate and the guardrails that you want to put in place for them. I think that's a key sort of decision to make as well.
Yeah, I think.
Cool. Cheers, guys.
I was going to say, there's a few oddities around CloudFormation that you need to be aware of in terms of how you deploy and how you make changes and stuff. It's a bit simpler to understand with Terraform when you've got the state. I would definitely just kind of read documentation and just see what those oddities are. It's quite well documented.
All right, I would say we're currently eating into the next talk time, but I reckon we've got time for one more question, and we'll just ask Alex to speak quickly. I'm joking there, Alex, by the way. Any more questions, or are we done? They will be at lunchtime at the Ask an Architect thing anyway, so which is over in the bar. I think that's all. Thank you very much again, gents.